When a block falls from a wall at Sacsayhuamán, it reveals something that should not be there. The hidden side, the surface that was buried inside the wall and never meant to be seen, is perfectly smooth. In Japan, where polygonal walls were built with documented hand tools over 3 centuries, every hidden surface is rough and covered in chisel marks. Because no mason would finish a surface no one would ever see, unless the blocks were never carved at all. Japan and Peru both have polygonal walls. Blocks of irregular shapes, fitted together without mortar, joints so fine you can barely see them. 2 sites on opposite sides of the planet with what appears to be the same construction style, except they are not the same. And the differences between them dismantle one of the most common claims in archaeology. Japan's polygonal walls are among the best documented ancient construction projects in the world. The techniques were recorded in Edo period literature. The evolution is traceable through 3 distinct stages, and Japanese masons still build these walls today using traditional methods. The earliest walls, dating to the 15th century, are simple stacks of natural, unprocessed stone, rough, gaps between every block, rarely more than 3 meters high. By the early 1600s, stones were shaped at the corners, joints were tighter, gaps filled with smaller rocks. Walls could reach 20 to 30 meters, a clear step forward. Then, in the mid-17th century came the pinnacle. Stones were thoroughly processed with iron chisels to interlock with extremely tight joints. Japan considered this the ultimate form of stone processing technology, a symbol of power reserved for castle gates and the most important walls of the ruling shogun. The practice never stopped. Japanese masons still maintain and repair these walls today, using the same hand tool techniques recorded in the Edo period. Stones are marked with pencil or chalk to indicate which sections must be cut, then chiseled by hand until the block slots into its intended position. Once a stone is fitted, the mason moves to the next. The work is slow, the result is tight, and every step of the process leaves a visible trace on the surface. 3 stages, crude to intermediate to precision, over 2 centuries of development, fully documented, and even at the highest level, with the best tools and the most skilled masons feudal Japan could produce, these walls have a specific set of characteristics. The exposed faces show chisel marks, detailed, recognizable tool marks from iron chisels and hammers. Japan has specific names for the finishing styles. Hatsuri produces short, evenly spaced chisel marks across the surface for a smooth, delicate look. Sudare creates vertical striation patterns. 300 years of weathering have softened some of these finishes, but their remnants are still visible at Edo Castle and the Tokyo Imperial Palace. Each carving system is documented in period masonry manuals and identifiable on surviving stones. The buried sides tell a different story. They are rough, unfinished, covered in crude chisel marks, because no mason would waste time finishing a surface that would never be seen. The joints, while impressive, are not perfect. At corners, the fitting loosens. The walls require separate drainage channels because the tight joints prevent water from passing through. And this highest grade work was so labor-intensive that no castle was ever built entirely with this method. It was reserved for the most visible, most symbolic sections only. The structural physics tells the same story. Most Japanese castle walls are retaining walls, backed by a layer of pebbles and compacted earth mounds. The stones are wedge-shaped. Only the exposed faces were chiseled, and the backs taper inward to sit against the fill. At Kanazawa Castle, displays show the interior cross-sections of the 3 stacking types. The embedded portions are rough, cut only enough to slot into the earth matrix. On many stones, daimyo engravings identify which feudal lord's workshop produced the block. A sourcing system is visible in the material itself. This is what the best hand tool masonry in history looks like: documented, understood, and limited. One more detail before the comparison. The Japanese walls are built from andesite, an igneous rock that rates 6 to 7 on the Mohs scale. The Peruvian blocks were long assumed to be andesite too, until a geophysicist at Sacsayhuamán poured dilute acid onto a surface sample. The stone dissolved completely. That is a limestone reaction, carbonate stone reacting with acid. Limestone rates 3 to 4 on the Mohs scale, far softer than andesite. The Japanese built their walls from a stone harder than anything the supposed Peruvian masons were working, and the Japanese walls are inferior. Now look at Peru. At Sacsayhuamán, Cusco, Ollantaytambo, and Machu Picchu, polygonal walls display joints that are tighter than Japan's finest. Some blocks weigh over 200 tons. The fitting is so precise that a single sheet of paper cannot be inserted into the seams. The curves are organic, flowing, interlocking in 3 dimensions, like a jigsaw puzzle designed by someone who understood geometry at a level that still challenges modern engineers. And there are no chisel marks anywhere. The surfaces are smooth. The blocks show no evidence of hammer strikes, no iron tool marks, no dressing patterns. Instead, there are shallow scraping marks consistent with screeding, the process of smoothing wet material with a straight edge. There are irregular knobs protruding from the lower portions of blocks, random in shape and placement, serving no structural or transportation purpose. The blocks bulge slightly, with a rounded, swollen quality that is uniform across thousands of stones. The standard defense of the Inca-built theory points out that Mohs hardness alone does not determine whether a tool can cut a material. A blade's edge geometry, abrasion resistance, and the force applied all contribute. Copper can work limestone if the chisel is sharp enough. That is correct. It is also beside the point. The Peruvian evidence is not that soft tools cannot touch soft stone. It is the absence of every expected signature of any hand tool cutting any stone. No chisel marks, no hammer scars, no dressing patterns, no progressive rework. You cannot cut stone without leaving cut marks. You cannot fit 200-ton blocks by trial and error without leaving trial and error. Jean-Pierre Pratzen of the University of California, Berkeley, spent decades studying Inca stonework. He demonstrated experimentally that pounding with river cobbles can shape andesite blocks and achieve tight fits through trial and error. His work is rigorous, and his experimental joints were tight, but they left pounding marks across every surface. The Sacsayhuamán blocks have none, and Pratzen's method does not explain the smooth, hidden faces, the bulging, or the screeding marks. There is the matter of the Inca toolkit itself. The Inca had no written language. Their record-keeping system consisted of knotted cords called quipu. They had no wheels, no carts, and no draft animals capable of hauling heavy stone. 200-ton blocks were allegedly quarried, transported up mountain gradients, lifted into vertical position, and fitted into custom curved joints, all without recorded plans, specifications, or construction notes. Every hand tool civilization in history that built at comparable scale left records. The Egyptians had papyrus. The Romans had inscriptions. The Japanese had their period manuals. The Inca left knots. Here is what should end the debate. When blocks at Sacsayhuamán have fallen or shifted to expose their previously hidden sides, every surface is smooth. The backs, the tops, the sides embedded inside the wall that would never have been seen by anyone are finished to the same standard as the exposed face. The Japanese proved what rational hand tool construction looks like. You finish what people see, you leave the rest. Cast concrete is smooth on every side by default. A block poured into a mold comes out finished on all surfaces without any additional labor. The hidden sides of the Peruvian blocks are not evidence of extraordinary craftsmanship. They are evidence that the blocks were formed as a material that hardened in place. The compression mechanism explains the rest of the signatures at once. Semi-cured blocks, still pliable, are set in place and pressed against their neighbors from above and from the sides. The material squeezes outward to fill every void between adjacent blocks before final curing. Bulging profiles, airtight seams, random surface knobs where material displaced through a mold joint. Every distinctive feature of the Peruvian walls follows from a single physical process. A hypothesis that predicts all the evidence with one mechanism is stronger than a hypothesis that needs a separate explanation for each. And there is the question of chronology. At Sacsayhuamán, the lowest courses are fitted to sub-millimeter precision. The upper courses, attributed to the Inca period, are rough field stones stacked with visible gaps. The precision came first, the inferior work came later. The boundary is visually obvious at every major site. At Ollantaytambo, the lowest courses show seamless polygonal fittings. Above that, stones are laid square-edged with wide mortar gaps. The transition is not gradual. One method ends, another begins. The natural reading is that two separate construction programs contributed to the same structure, separated by enough time that the later builders had lost whatever method the earlier builders used. This is the opposite of what Japan demonstrates, where construction technology progressed from crude to sophisticated over centuries. If the Incas built these walls, they started with perfection and regressed to rubble. That does not happen in any documented civilization. What does happen is that a later culture finds the remains of an earlier one and builds on top of it with whatever skills they have. The Incas left no written record of how these walls were built. There is no contemporary account confirming the method. Peru has none of these signatures. No tool marks, smooth, hidden faces, precision that exceeds Japan's best work, and a chronology that runs backwards. two sets of polygonal walls on opposite hemispheres. One was carved, one was not. The chisel marks tell you which is which. If you want to support deeper research and found this journey as fascinating as we did, subscribe to Ancient Epochs for more.